let's kick it off here with getting it into standard form. Now, a couple things. On the board over here, I've left the ellipses and hyperbolas. Phones away, we're focused on math, please. Now, ellipses, remember the order is always x plus y. Hyperbolas, it switches depending on where your subtraction is, because you want that minus in between. So when I look at this equation, I'm like, okay, I see the 9y squared is positive and x squared is negative, so I'm going to keep it in that order. I'm going to keep the y's up front and then the x's behind it, because we want the minus in between them. I'm going to put, let's see, 54y with that. And then I'm going to do the x's. Minus x squared. And like always, let's just subtract 62 and get it out of our way. Thank you. Okay, whenever you complete the square, of course, leave coefficient 1, so we're going to pull the 9 out. 9 times 6, 54. Okay, I'm just going to kind of set it up over here. Get my negative 62 there. All right, nice and easy. Nice even number 6. Complete the square on 6. Half of 6. 3 squared. 9. Got it. Careful. We're not just going to instantly put a plus 9 on the right side. You're going to put what number? 81. Landon, put your phone away, please. Focus on math. We're on the home stretch, my friends. All right, for x's, before I get crazy and do those, I have to factor this negative 1 out. Now, what's the sign going to be on 2x? Negative. Negative, negative makes positive. I'm running out of room. Complete your square on 2. Half of 2 squared. What are you putting on the right side to balance that? Negative 1. Good. Negative 1 times 1. Got it. So careful. I feel like every math teacher says this every day. Careful of the signs, right? All right. We can factor y squared plus 6y plus 9 into y plus 3. Nice and easy. We can do the blue x's. Multiply to 1, add to negative 2. And we're going to total up that right-hand side. We really have 80 minus 62. 18. And remember, for standard form, for both ellipse and hyperbola, just reviewing, has to be set equal to 1. So I'm going to reduce 9 over 18. That's 1/2. I'm just not going to write the 1, of course. Let's put over 2. Really love the over 2 and the 18. Because notice neither of those are perfect squares, so we're going to have to approximate some decimals, and I did that on purpose. Okay, next question. Watch the order, watch the signs. What's your center? Perfect. 1, negative 3. Positive 1, negative 3. Keep x where x belongs. Same with y. Let's go ahead and plot that. Now, square root of 2, for whatever random reason, I just know that one. We use that a lot. That's about 1.4. So it's under y. I'm going to estimate best I can, up 1.4, down 1.4. No promises. Okay. Square root of 18. I know that can be simplified, and I might have to do something with that, but for right now, I just want the decimal approximation. You see, I got to look for that one. I don't use that one a whole lot. 4.2. So right 4.2, left 4.2 from your center. Estimate it. 1, 2, 3. Okay. Now, purpose, remember, of the 4 dots is you can now make your central box. If there was a plus in the equation, it'd be ellipse, we'd draw the oval, we'd be done. But hyperbola, this is going to be fun where it's not on nice whole numbers. So central box. Purpose of the central box is now you can draw your asymptotes. They go, remember, from the center to each corner. And we need the asymptotes because that determines how wide it is. Now, next question for you before I get ready to draw it. How does our hyperbola open, horizontally or vertically? Vertically, perfect, because y comes first. So I'm going to take this red point at the top, draw close, not cross or touch. Try not to anyway. Same for the bottom. And we're ready to answer all the stuff. We'll do foci in a minute. Now, I intentionally made one with a lot of square roots so we can practice writing those ordered pairs exactly. Remember, from the center, you went up and down to get the vertices. So we went up and down a square root of 2. Am I going to apply that square root of 2 to the x coordinate or the y coordinate of the center? Y, because you went up and down. So the x stays, And we're going to do plus or minus square root of 2 to the y. Let's do lengths of transverse axis. Now, that's the length of the axis that connects your vertices. You went up a square root of 2, down a square root of 2, for a total of, how many square roots of 2? 2. I'm going to go ahead and do slope of the asymptotes right now. Now, this would be a hard one to count rise over run because of the decimal, so I'm going to go off the equation. The rise, of course, was square root of 2. The run was square root of 18. First glance, I was like, oh man, I got to rationalize. No. Both under roots, you could reduce them. What's 2 over 18? 1/9, which is even more excellent because they square root out nicely. What's the square root of 1? Square root of 9. So we got plus or minus 1/3. Okay. The last thing we have to find, I'm just going to scroll it up a little bit so I'm not clear at the bottom here. We have to do our foci. Now again, come test day, all this stuff will not be on the board anymore, but easy enough to remember foci. If it's minus in your equation, your foci switches to a plus. So I'm going to do 2 plus equals 2 plus 20. And then, of course, we're going to get rid of the squaring with the root. Okay, square root of 20, of course, that's not super common. I had to punch that in my calculator. It is about 4.5. So again, that's inside the hyperbola. So from the center, up 4.5, down 4.5. Estimate it, right? Let's see. 1, 2, 3, 4. 1, 2, 3, 4. Got it. Now I need exact coordinates. And square root of 20, while we're here, let's simplify it. That's 2 square roots of 5. 4 times 5. Now, it went up and down. So does that affect on your center the x or the y coordinate? Y. So the x stays, and we're going to put our plus or minus 2 root 5 on the y. So is the homework all this bad with all the crazy radicals? No. But of course I wanted to do one to kind of practice of where to put those radicals on the center, which coordinate. Any questions I can answer on this one? All right, let's take a look at the next one. So same thing, we have to get it in standard form. Now, notice this time the x squared is positive, so I'm going to keep that up front. I'm going to put 2x with it. That's kind of nice. We won't have to factor anything out. And then our 9y squared, our 54y, and we're going to add 80 over. Now, nice thing, like I said, about the x's, you have a lead coefficient of 1 on the x squared, so we're ready to go there. Half of 2 squared. And no distributor on that one, so I don't even hardly have to think about it. I can just throw a plus 1 over here. Okay, y, I'm going to do some work on. We're going to take that negative 9 out. So I'm going to have minus 6, negative 9, negative 6, positive 54. Half of 6, 3, 3 squared, 9. Okay, what balance is that? I really put what number on the left? And I'm pretty much done. Why do I say that? Right hand side is 0. How are you going to set that equal to 1? I can't divide by 0. We can't do it. You can write no solution, not possible. I'm going to get fancy. This is what we call a degenerate conic. I just like to say degenerate, especially in this class. And if you write not possible, no solution, that's fine too. All right, any questions on that? Now, like I said, I am going to do a little bit more on the equation writing than I have in some of the others, because we got to make sure we have this down. Because of course what we do today is similar on ellipse, on all the other figures. And I did give you graph papers today. I think it's helpful to have the graph, okay? Questions? Dino, question?
Yeah, actually I do have a question.
Sure.
So why is that light so bright? Like, did you guys just fix it?
That's above my pay grade, Dino.
Okay, well, should I talk to Mr. Doherty about that? Because that's really...
That's who I would ask, yes.
Okay.
All right.
I'll get into contact.
Center at the origin. Catch that. Now, like I said, on the test, I will give you a sheet of graph paper. I actually put them on your notes because I think it's helpful to have the grids. I don't know, maybe it's not too, but it is to me. Vertices, let's plot those. 0, 2, 0, negative 2. Now, normally, first thing I do is kind of set up the equation when we did the ellipses, but I haven't yet because I need to figure out first how this thing opens so I know if I'm starting it with x or y. Well, if the vertices are here, it's going to, of course, open up and down. So I'm going to start my equation. Now I'm ready to set something up with y. And since we're centered at the origin, no number with y, let's fill in the x squared, same thing. So it's all about getting these denominators. That's the hard part. Well, center to a vertex. You can calculate how many units from a center to a vertex. How many units? How many units center to the vertex? 2. You're going to obviously square that. Where are you putting the 4, under x or y? Y, because you're going up and down. You're moving up 2 and down 2. That's your y distance. Now, our next thing they give us, which I haven't even marked yet, they tell you the foci. It's 0, 4 and 0, negative 4. So you now know what C is. C, remember, is the distance from a center to a focus point. How many units? I'm just going to do this one so I don't make a mess here. From the center to the focus point? 4. So we know C squared is 16. So I'm using my C squared equation now. So 16. Okay. In theory, let me ask you this. Notice I didn't get crazy and write, ooh, is A2 or B2? Does it really matter? No, because if I throw 4 in here, I know I'm going to end up with what for the other one? 12. Okay? Technically that is A. The distance from a center to a vertex is A, but it really doesn't matter. We're going to get 12. Got it. So I do think it is helpful to mark a little bit out on the graph, so that's why I put the graph grid on. And we're going to do a few of these, like I said. Okay, same thing, center at the origin. We haven't switched. That's the next example. Vertices at 1, 0. And I just label V so I know it's not a focus point. Okay, now that's important. I can tell you right now, how would this one open? Horizontally or vertically? Horizontally, because it's on the sides. Not that we need my great artistic drawing here. So I know I'm going to start with x squared, since it's horizontal. Okay, next up, I can tell you the distance. You can look at it and figure out the distance from the center to a vertex. How many units, obviously? 1 squared. Okay, so are you putting the 1 under x or under y? X, because that's how you counted horizontally. And technically, if we're going to, for the thrill of knowledge, that is A, the distance from the center to the vertex. Now, a little different this time. They tell you the asymptotes versus C. It's almost easier when they give you C. Now, asymptotes, we work off the slope, the number in front of x. I'm going to write that fraction form, just for dramatic emphasis. So if I plotted that, I'd go up 5 over 1. Well, I already knew the over 1, so I know B has to be 5. We went up 5. Well, what's 5 squared? 5 squared? 25. Because I know if we graph those, we went over 1, I kind of lost the 5 there, then up 5. So that wasn't too shabby. Okay, final one of these and we'll switch where we're not centered at the origin. Okay, foci, well let's put the center on, we're still at 0, 0. Foci, 0, 8. I don't know if I love this one. Okay, so I got some knowledge here. Question for you. First question, easy question. How would this one open? Horizontally or vertically? Vertically, because the foci are top and bottom. So I know y is first. Next question. Do you know the vertices? We don't know what A is. Okay, all right. So that's a little problematic. We do know what C is. I can at least tell you that. So I know C is 8. the distance from the center to a focus. So I think about my c squared equation, which isn't super helpful because, I don't know a squared or b squared right now. Working on it. But I do have this slope. So I'm thinking about it like the last one, my slope, of course. My fraction form. Gotta love a fraction. Now, for the slope, of course, okay, here's where it gets a little tricky on this one, where it's different from the earlier one with the slope. Here is the difference, my friends. How do I know that that 4 over 1 isn't really 8 over 2 or 12 over 3 or some other form that reduces down to that? I don't know that. Where like this one I did. They told you where A was. I counted it. I knew A was 1. I didn't have to worry about it. I have to worry about that here because I don't know that. So that's our B over A. Okay, now, basically what we have here, get ready for it, this is a great problem, I really love it, is a system of equations. Now, first things, before I even start thinking substitution, elimination, any of that stuff, let's clear the fraction here. So I'm going to rewrite this one as 4a equals b, just to get the fraction gone. Now, personally, I think this would be a hard one to do elimination style. I know it's everybody's favorite. I would probably go substitution. If you know b is 4a, I'm just going to substitute it in up here. Let's see what we got. 64a squared. Now, if I put 4a in there, square that for me. What's 4a squared? 16a squared. And remember, we're solving for a squared. It's not going to be as bad as what it looks. I'm going to add the 1a squared, the 16a squared to 17a squared. And then I'm going to divide that off. Now that's super gross, okay? I'm aware of that. It doesn't simplify, it doesn't reduce. There's your first denominator, as weird as it is. Let's do b squared. Now, I would just, of course, use back substitution. If you know a squared, I'm going to come up to this original equation, and I'm going to replace the a squared with 64/17. Just like if it was a nice, pretty number, I'd just pop it in there. Now, I did this on my calculator. I wouldn't do this by hand. You'd have to make your common denominator 17ths, all that good stuff. So let me look. I can't remember what the crazy fraction was. It's 1,024 over 17. Love it. So there's your second denominator. Now, thank God we don't have to graph it. If I were to square root these and divide them, what number would you turn out to equal? It's up here. What's the slope? 4. If you square root those and divide them, it calculates out to 4. That's a different form of 4. Now, I was hoping we'd have maybe like 8 over 2, 12 over 3. No such luck. Now, is there going to be this one as crazy as this on the test? Might be in a bonus style problem, but we can handle it.
Oh, so that's not going to be on.
Never know, never know. Okay, standard form. Now, notice, home stretch. Here we go, people. Notice our center is not at the origin, so we're going to have to find that, but it's going to be pretty easy. Vertices at 2, 0, and at 6, 0. Got it. Okay, either just look at it, or use your old school midpoint formula, whatever. Where's the center? 4, 0, yeah, right there in the middle. So I'm going to jot down my centers at 4, 0. Okay, I can also tell you which direction would it open, horizontally or vertically. Horizontal, so I'm going to start with X. And I'm going to include the minus 4 this time. All right, we got a lot of good info here. I can tell you the distance from the center to the vertex. 2. What's 2 squared? 4. That's going to go under X since we're moving left and right. And foci, I should mark those 0, 0, and 8, 0. Well, I can tell you now what C is. What's the distance from a center to a focus point? 4 units. c squared. We can mental math it. What's b squared? 12. That's not so awful, is it? The equations are definitely the tougher of them all. All right, final two, my friends, final two. Vertices 2, -3, and 2, 3. Got it. All right, right now you can get the center for me. Where's the center? What's the center? What's right in the middle of those green dots, people? Which is what point? Ordered pair. 2, 0. Thank you, Estelle. Next question. As I'm grabbing stuff. How's it going to open? Horizontally or vertically? Up and down vertically. So I'm going to start with y. Now, our y coordinate center is 0. I'm just going to put y squared. And then we'll do our x minus 2. Okay, you can figure out what a is. From the center to a vertex, how many units is that? 3. 3 squared is 9. Where are we putting 9 under x or y? Y, because it's your up and down. Interesting. Now we got a glitch. Goes to the point 0,5. Well, that's pretty exciting. Okay. Ordered pairs, x comma y. So my only other choice really right now is to plug those in. So I'm going to put 5 in here. Okay, well, it's kind of gross, but whatever. I'm going to put 0 in here with 0 minus 2 and then squared. 0 minus 6, 4, yeah. And we're trying to figure out b squared. I don't know what this is. That's what I'm working on. So here's my problem. We just have to manipulate this equation. We have to solve it algebraically for b squared. You have a couple choices. You could subtract 25/9 off with your calculator. You could clear out all the fractions right now. It doesn't matter. I'm going to clear the fractions because I know you guys hate fractions. Denominators are 9 and b squared. So I'm going to multiply everything by a 9b squared. So when I multiply this first fraction with 9b squared, the 9's cancel. You're left with 25b squared. When you do the middle, the b squareds cancel. So you're left with 4 times 9, which is 4 times 9? 36. And then we're going to have 1 times 9b squared. So I'm just going to get the b squareds on the same side. I'm going to subtract 25 over. What's 9 minus 25? Negative 16. So I have negative 36 equals negative 16b squared. And we're solving for b squared. Okay, 2 negatives, of course, make a positive. Can you reduce 36 over 16? Yeah, 4 goes into both. 4 goes into there 9, 4 goes into 16, 4. So 9/4. That wasn't that bad. We just had to do a little algebra to solve.
That was bad.
That's not that bad. Come on.
That's the worst that we've dealt with.
I can't wait till you're in Calc 1 next year. Okay. Final one. Ready? Okay, vertices 0, 2, let's plot them, and 6, 2. First question, what's the center? Center is 3, 3. So we've got our center. Next question, how does this one going to open? So I know if I should start with x or y. Sideways because your vertices are on the ends, left and right. So I'm going to start with x. So x minus 3 squared. Y minus 3. Okay, so next up, I'm just gonna count how many units from the center to a vertex. Clearly it's 3. 3 squared is 9. Where am I putting the 9? Under X or Y? X, because that's left and right. Sophia, what are you going to ask me? I can tell you have a question. What do you guys have for a question?
Did you mark with the V's, the vertices? Why is it on 3? Wait.
Oh, so I'm up 1. It should be 2. You were right.
Yeah, wait, is it supposed to be
You were right.
2?
Sorry. Yes, no, you were right. You were right. No, I'm sorry. No, you were right. No. No, I'm battling a cold, and this is what you get. Let me put this back on red. Sorry, guys.
That's like really high right now for 2.
That is my poor graphing skills. Okay. So I'm just going to change this to a 2, which is going to erase. I hate this eraser. I need it to be a little smaller. Good catch. That's my bad. Okay. Just move it down 1. Final question of the day. We need obviously that second denominator. So of course I'm looking at these equations and it's all about the slopes. The number in front of X. I don't care about the 4, we care about the 2/3. I don't even really care so much about the plus or minus. I care about the 2/3. Because I like this one. So it's not like the other problem where I'm like, oh gosh, is that the simplified form? Is it 4/6 or some other version? No. Because you know this is 3, you know it. So you can assume the other value is 2, and 2 squared is 4. Done. That's it. So because you knew A was 3, you could just use that other value off the slope. You didn't have to worry about, is it some weirdo simplified form like that last one was. Okay, so let me grab your homework for you. Just figure a time.